Okay, this is 5.5. We are proving triangle congruence by SSS. SSS means side, side, side. And we're going to be proving triangle congruence by this theorem. We're going to be starting in GeoGebra again today. They want us to create a circle with a radius of 2 and a circle with a radius of 3. So that's what I went ahead and did. And then they want points on both of these circles, okay? The reason for that is we want to create a triangle where these segments stay the same. So AD, that's going to be 3. Okay, or actually, I don't like these letters showing up. How do I know it's 3? I can find the distance between these two. And in GeoGebra, when you put a point on a circle, okay, that point doesn't move from that circle. So no matter where you go on that circle, the distance will always be 2. Okay. Just going to delete that distance. We want to create our triangle here. And then I don't like these letters showing up, so I like to hide those. So we have just a nice clean triangle. Okay. They also want us to make that third side a length of 4 units. So this side, ED, has to be 4 units. I'm going to go to distance. I'm going to go to E to D. Notice it's at 3, so I'll have to move that to 4. Okay. One thing I want you to notice. We are working specifically with angle measures in this unit, okay? Look here, if I move E just even a little bit, look how much wiggle room there is when ED is 4. Okay, this is from 4 all the way to 4.9. So this is almost like a whole inch of error. We don't want that. Okay, we want to be as specific as possible. To change that settings, we have to right click, we have to go to settings, and then over here on the settings button, we have to round to more decimal places if you want to be exact. I'm going to say 5. 5 should be pretty exact for us. And look, we were at 3.9. We weren't even at 4 yet. So change this to, we want to get to as close to 4 as possible. Okay, that is pretty close. If I go to 4.00. Oh, great. Again, it's a little tricky. Come on. Oh, come on. There we go. Okay. Maybe 5 decimal places is a little too much. Maybe we should go 3 instead. 3 might be best. Okay, and it's at 4.007, which is good enough. Next, they want us to find the angles of A, B, and C. So we want to find the angles of our triangle. To do that, we go to angle. Find each angle. So angle A is going to be 104 point whatever. Angle E will be 29 point whatever. Angle. So I'm going to move these so it's a little easier to see. Okay. And then we need to keep track of this. So I'm going to write these down so off to the side so we can see it a little bit. Let's say angle A is 104.2. Angle E is 29 point, we'll say 25. And we'll say 104.22. Angle D is equal to 46.53. Okay. It's a good thing to keep those numbers in mind because they want us to repeat this process more than once. So what we're going to do is I'm going to move E. Oh, not that. I want to move E just wherever. I'm going to move it down here. Okay. Now we want ED to be as close to 4 as possible. Right there. That's as close as we're going to get. Okay? Now, what are the main angle measures here? Angle A is 104.017. 104.017. Angle D, or angle E, angle E is 29.32, and angle D is equal to 46.66. Okay, now compare these. Compare these measures. Are they the same? No. Why is that? Well, it's because that third side, on GeoGebra, it's hard to make it exact. But we're getting at a concept here, and I want you to get this concept in your head. All right? When we have three congruent side lengths, or three side lengths of the same measure, so our first triangle had the same side lengths as this next triangle, they are going to be congruent triangles. Now, are our side lengths exactly the same as our first one? No, because we had 4.002, and the last one we had 4.007. But again, I'm just getting this in your head. Okay? Notice how close these angles are. All right? That is what we're going to be working with today in lesson 5.5. Is when triangles have the same side lengths, they are congruent. So number two, what can you conclude about two triangles when you know the corresponding sides are congruent? All angles are congruent. Okay. So if we have three sides congruent to three sides of another triangle, then we know that each corresponding part of those two triangles, are congruent. Number three, we kind of just proved it. We're not going to talk about any more of that on number three. We're going to instead go down to these definitions. All right, 5.5, we're talking about legs. All right, legs are working the same thing as last lesson. Legs are in an isosceles triangle. The two congruent sides are the legs. All right. The hypotenuse. The hypotenuse is in a right triangle. So it's a right triangle. The hypotenuse is the angle, or the side, opposite 90-degree angle. So, in a right triangle, the hypotenuse is the side opposite the 90-degree angle. Okay, so it's the side opposite to the 90-degree angle. That is the hypotenuse. A few definitions and theorems that we'll be working with. Side, side, side. Right, so we're the basics of this lesson. If three sides of one triangle are congruent to three sides of the second triangle, then the two triangles are congruent. Notice, they said if AB is congruent to DE, so AB
is congruent to DE. BC is congruent to EF. BC is congruent to EF. And AC is congruent to DF. Then ABC is congruent to DEF. Notice, order matters. Order matters. Okay, they said AB, side AB is congruent to DE. AB, DE, AB, DE. Okay, make sure, order matters, especially in this lesson. Well, in all lessons, order matters. Hypotenuse leg congruence theorem. If a hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second triangle, then the two triangles are congruent. Okay, so we have our hypotenuse, and they're congruent to each other. Okay, and then one leg. If that's all we have, okay, those two triangles will be congruent. Let's get to some example problems. I didn't miss anything, right? Yeah. Okay. Let's get to some example problems. Decide whether the congruence statement is true, and then explain your reasoning. Okay, this first one, they said ABC is congruent to EDC. So they said ABC is congruent to EDC. One way we can look at this and say if this is true or not. Okay, look at the first two letters. They said AB. Okay. Is AB congruent to ED? And I'm talking is AB congruent to ED? Is this a true statement? Well, between A and B, there's one tick mark. So between E and D, there has to be one tick mark, which there is. Good. Okay. Another way we can tell is BC congruent to DC? Well, between BC, there's one tick mark. Between DC, there's one tick mark. So yes, that is true. Okay, so we know for sure they have their order correct. These two triangles are congruent, so true. And I just kind of explained it. This next one. KGH is congruent to HJK. So let's start with that first segment. Is KG congruent to HJ? Well, between K and G, there's two tick marks. Between H and J, there's two tick marks. So that statement checks out. Good. How about between G and H? Is that congruent to J and K? GH, JK. Are those congruent? Well, between G and H, there's one tick mark. And then finally, look at the first and last letters. Is KH congruent to HK? Is KH congruent to HK? Well, yeah, it's right in the middle, right? And that side length is congruent to itself. So yes, those check out. Here's your reasoning right here. Here's your reasoning. This whole thing. That is your reasoning. Okay, those three sides are congruent to each other. So by side, 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 they are congruent. Moving on to number 3. UVW is congruent to XYZ. Again, start with the first two letters. UV and XY. Is UV congruent to XY? Between U and V, there's one tick mark. Between X and Y, there's one tick mark. Good. So that checks out. How about VW and YZ? Is VW congruent to YZ? Well, between V and W, there's 3. Between Y and Z, there's 2. So, no, this is not congruent. No, not congruent. That is not a correct congruent statement. What is VW congruent to? VW is congruent to XZ. Okay. And UW is congruent to YZ. So the correct congruent statement would be triangle UVW is congruent to YXZ. Okay? That's what I'm saying, order matters. That is not a correct congruent statement. Those are not congruent. Okay? The triangle I wrote, those two triangles are congruent. Lastly, RST is congruent to RPQ. Here's a quicker way. RS, there's 1. Between RS, RP, there's 1. Okay. Between S and T, there's 2. Between P and Q, there's 2. And then lastly, the third. So, yes, all sides are congruent. Okay, so a few different ways to describe these. You can get somewhat unique with it, but all in all, we have to make sure our order is correct. Number 5 says, determine whether the figure is stable. Explain your reasoning. Okay, so what I want to ask is, imagine these are bolted in really, really well. Okay. Can this shift either way? And the answer is no. Why? Because this right here creates a congruent side. Okay. So this is stable. Why? Because of side, side, side. We created 3 congruent sides of the triangle, and if this moved either way, which it can't, because this side length can't change sides. Okay, so it is stable by side, side, side. Lastly, we have a few proofs. It says redraw the triangles so they are side by side with corresponding parts in the same position. Okay. I'm going to do this over here on the side. We have A, B, or A, C, B. So C, B, A. And then E, D, B. So E, D, B. Alright, now it says write the proof. So you want to prove this triangle either by hypotenuse leg or by side, side, side. Okay, or side, angle, side, whichever one we need. First things first, write the statements, write the given. B is the midpoint. OCD. Reason? Given. You guys are good at that. You guys are good at that one. What can we say then? Oh, let's just keep with our proof or our given here. AB is congruent to EB. All right. And angle C and angle D are right angles. Okay, 2 given. Sorry, my handwriting gets a little sloppy with these. Okay, now I have to prove that these triangles are congruent. How? Well, we can prove it by hypotenuse leg. Remember, if we have one leg and a hypotenuse congruent, So we already have a hypotenuse. That's given to us. It's the side opposite the right angle. Those are congruent. Now we just need one leg. Well, if B is the midpoint of CD, B is the midpoint of CD, that means these side lengths are congruent. So we can say that CB is congruent to BC. What's our reason? Definition of midpoint. Okay? And then finally, look at that, we have our hypotenuse, and then our leg. So we have triangle ABC is congruent to triangle BBDY because of hypotenuse, leg. Okay, there it is. Got it. Lastly, final proof. I'm not going to do this one in depth. I'll leave that one up to you guys. What I want to make sure you guys know is that there's a lot of stuff going on over here. And make sure you pull out the right proof. EFG, so start at E, EFG is congruent to HIJ, which is HIJ. Okay, make sure you guys work on those congruent statements. All right. Good luck. That's a great one to practice on your own.